Welcome to AEL. In this video, we will see how we can adjust the duty cycle on astable mode of operation for any application. Because the charging path is longer than the discharging path, the high time of the pulse is always longer than the low time. This means that in a standard 555 astable circuit, the duty cycle is the ratio of high time to the total period, which is always greater than 50%. The exact duty cycle is determined by the sum of RA and RB, divided by the sum of RA and 2 times RB. So, if you want a perfect 50% or even a lower duty cycle, you cannot use the standard circuit. The most common and effective method to achieve a duty cycle of 50% or less is to add a bypass diode to the circuit. Place the diode in parallel with the resistor RB. The diode's anode should be connected to the junction of RA and RB, and its cathode should be connected to pin 6. When the output is high, the capacitor charges. The current flows through RA and the diode bypassing RB. This makes the charging time dependent on just RA and the capacitor, C. Now let's say in an interval of 10 seconds we want to turn an LED on for 3 seconds and off for 7 seconds. Total period is 10 seconds. On time is 3 seconds. Off time is 7 seconds. Duty cycle is 30%. This is exactly what the diode-modified astable mode is for. With the diode, the ratio of RA to RB equals the ratio of on time to off time. So, RB is given by the ratio multiplied by RA. High time is given by 0.693 multiplied by RA and capacitance. Low time is given by 0.693 multiplied by RB and the capacitance. Summing the two will give you the total time. The duty cycle is the ratio of RA divided by RA plus RB. RA equals 430 kilo ohm. RB equals 1 mega ohm. Let's pick a practical capacitor. Say C equals 10 microfarads. Diode, in parallel with RB, cathode to pins 2 and 6, anode to pin 7. Let us simulate these on Proteus and see the result. This is the 555 timer IC. This is our charging resistor RA and our discharging resistor RB. This is the capacitor C1 that charges and discharges, giving us an output signal. We also have a stability capacitor C2. Notice the value for RA is 430 ohms, which is not exactly what we calculated. That is because I chose to use a standard value close to it. Same with RB. The capacitance of our capacitor was chosen to be 10 microfarads. Our power supply is 5 volt. The output is pin 3, where we have our LED connected to it and an oscilloscope to visualize the output waveform. Also, we have our diode in parallel with RB. Let us run the simulation. We should see how the capacitor charges and discharges. There it is. The capacitor is charging and at a certain point it discharging. Let's switch the oscilloscope to DC. Here we see that the LED is on when C1 is charging and off when it is discharging, giving us a high and low output waveform for 30% duty cycle. That means the LED comes on for 3 seconds and goes off for 7 seconds. In our next video we will look at the monostable mode of operation. If you found this helpful, don't forget to like and subscribe to AEL. Keep experimenting, and see you in the next video.